one of those presentations a while back where he created swing interfaces in basically all kinds of different languages. I'm just going to decrease the font size here a little bit so it doesn't wrap. Okay. So this is two different ways of doing imports. This one will do an import of two different classes from the same package. Symbols start with colon. You can use colons inside of things, and that's how I handle the fact that dots are actually terminators in Ioke. So instead of using dots, a dot is replaced by a colon for Java names. I can create a new J button, or press me, and then do something in that context. Here I add two action listeners. Fn creates a new lexical block. That lexical block will call set text with hello from Ioke, and also print some stuff. JFrame will set the layout. Notice that I'm converting set layout to layout equals add button set size visible. Nothing really fancy there. And it's not really using the features of Ioke that's interesting. So I have this other example here that shows a Parser generator, or a Parser combinatorial library. So this is pure Ioke syntax, but inside of the context here, these things doesn't mean exactly what they mean outside. So for example, the number 9 here will actually return a number parser instead of the actual number. The strings will return string parsers. Dot dot is the range operator outside of the context, but it will return a range parser and assign it. So this is actually more or less BNF like syntax that will actually generate useful parser combinatorial library. And I can do this for a various number of reasons, and I knew that I was going to run out of time quite quickly on this one. So the workshop tomorrow is going to be half going through these things in more detail and actually look at the things that are interesting that I didn't really get a chance to look at. And also look at why this is really, really hard to optimize. Basic, let's say, something very, very simple can look like this. You define a method with the method. So the syntax is very regular here. Actually, I'm going to do it like this instead. One of the things that operator shuffling does is reduce everything into a canonicalized form, which means that if I do foo equals var like this, and then do var equals method x foo 32, I don't know, this is just array indexing and so on. This will be translated. So the AST that will actually be executed is going to be a call to the assignment operator, and then it's going to be reduced to a method call like this. This one will be the same kind of thing where you have equal sign, var, and then method, and this call is actually going to be translated into call to square brackets method and sent an argument like this. So this kind of canonicalization means that it's very, since the actual AST is very, very simple when it comes, everything is a message. Everything has arguments, everything has an next and previous pointer, which means that the macros are actually, it's possible for the macros to do whatever I want. And quite a lot of the library is actually implemented in terms of the macros. And I have a few interesting things that result from these things. First of all, I didn't really go into this, but if you looked really closely at the execution model, you would have noticed that there is no way of handling global state, because there is no global state. Everything is part of the inheritance hierarchy. So for example, stuff like nil and true and false is actually defined quite high up in the inheritance hierarchy, and it can be overridden if you want to. Literals. Creating a literal is actually sending a message to create that literal, which means that in the Parser combinatorials library, I can override that in a specific subcontext to get a number to return a number parser instead of an actual number. Methods could be implemented in terms of macros. There's nothing a method is doing that the macros couldn't do. Fourth point that I didn't really notice say here is that assignment is also a message send and can be overridden and done whatever you want to do with it. Let's see, I mentioned T2D. I have about 4,000 specs right now. Testing framework called iSpec. It's organized in such a way that I have a documentation generation tool that generates HTML from the living structure of the after the language starts up. I can generate documentation based on the full structure of the language. And I combine that with the specifications. So my documentation actually contains the, first of all, it contains the code if it's an Ioke, of course. It contains the documentation string, and it also contains all the specs for that specific method and the code for those specs, which means that the documentation contains all the information that you would really need to understand a method, unless you really want to write new tests for it. I have lots of future plans. Come hear about them tomorrow if you're interested in this stuff. I'm just going to go straight through, and yeah, there were quite a lot of stuff that I didn't cover. So I host this on GitHub and have a great community. Condition system is really one of those things that I'm missing from other languages. It's obviously implemented in terms of exceptions. Nothing more is needed. I have aspect system and comprehensions. Both of those are implemented in terms of macros, and there's lots of other stuff too. And I think that according to this one, I'm actually 1 minute left for questions. Yes, Leo.
If you had started out with the goal of having the data structures of the language be immutable, how would that have changed what you might have done?
Oh, that's a very, very long question, and a very long answer. I would say short. If I were about half as smart as Rich, I would probably have gotten close to closure. But I wouldn't have gotten all the way to closure unless I was as smart as Rich, of course. No, the whole idea of this language is based on the fact that you modify everything. Prototype-based, object orientation, based on mutation. I had some ideas on how to apply static typing and type inferencing to the system, and I think that would look quite a lot like structural typing, but actually applied to values. And in that case, it would be more interesting to see what could be done with immutability and so on. But that's just an idea back here that if I ever get a year, I could possibly try to implement that. Any more questions? Okay, thanks for your attention.